My name is David, and this is the program for the encryption exercise of CST210. For this exercise, we were asked to simulate the Caesar cipher in C++. The Caesar cipher is an encryption algorithm where all the letters of the message are shifted a fixed number of places, resulting in a non-readable message. Let's run the program. The program starts by prompting the user the shift value. Once he enters 714, the program now prompts the user to enter his message: sugar, salt, honey, chocolate, bacon. Now let's type quit, and as you can see, we get two columns, one for the original message and another for the encrypted message. Now, the program prompts the user if he'd like to see another encrypted message. He does, and this time he enters 8, he enters his message, and gets his result. Let's dive in the code. We first started off by including 4 libraries to use throughout the code, 3 of which we used in the previous exercise. These 3 were the iomanip library to align the message to the right, the vector library to use the vector class, and the algorithm library to display the encrypted message in lowercase. For this exercise, we included the string library for the string class. The code begins in main, where 5 variables are declared. First, we have an int variable called shift_key, which will later be used to represent the key to shift the message. Next, we have 2 string variables, user_message to represent the user's message, and the user_answer to check if the user wants to encrypt another message. Here, we have 2 vectors of type string, words and encrypted words. These 2 vectors will be used to store the message before encryption, and then the message after encryption. Later on, you will see why we used vectors rather than other simpler ways. Following these declarations, we have a do-while loop that iterates while the user's answer is yes. Inside of this loop, we prompt the user to shift value and read it. And if you're wondering what this cin.ignore is, it ignores the new line character after the shift value input to clean what is remaining in the console. Input buffer. Here we have a caption prompting the user to enter his message. Moving on, we have a string, word, where we will store each of the words of the message and then add each of the stored words into the vector words. Then, for each word, we will encrypt it using the encrypt function which returns the encrypted word. This while loop will continue executing until the user enters the word quit. Inside of the encrypt function, we have a for loop which does the actual encryption of a message. This if statement checks if the current letter of each word is a lowercase or uppercase letter between A and Z, and if so, it adds the key to the letter. This comment was a former endeavor of adding the key to each letter. But then I ran into a problem. Because a char will only represent values from 0 to 255, if I add a shift value greater than 256, rather than surpassing 255, it will actually loop back to 0 because of an automatic modulo operator for a char. This entirely messes up my simple addition. So I had to come up with a different way of adding a key. This is why this is here. I am storing the addition of the letter and the key in an int variable j. Because j is not a char, it is an int, it will not automatically apply the modulo operator to the value. Okay, so that solves that part. What happens when the letter is a lowercase z, and we try to shift it higher? Isn't the lowercase z the highest letter there is? Well, we could look at the ASCII table and look what comes after z, a curly bracket. But we do not want that, because for our Caesar cipher, we do not want non-letters encrypted in our encrypted message. So what do? After z, we go back to the letter a. We loop back to the letter a. But how do we do that? If the current shifted letter is greater than z, divide it by 26, get the remainder, and that remainder will be the new letter. If you think about it, it works. Or does it? To understand this, let's pretend that z is 26, and you shift it 3 positions to get 3 more after z, or 29. We can get the remainder after dividing it by 26, and we will get 3, or c, which is what we want. Unfortunately, c is not 26, it is 90. So if we try to get the remainder of dividing it by 26, we will get 15, which is not what we want. So what we need to do is, rather than having the range of the lowercase letters from 97 to 122, we have to have it from 1 to 26. To do this, we subtract a from the current letter, find the remainder of dividing that current letter with 26, and then adding a again to get the letter back in its original range from 97 to 122, rather than from 1 to 26. And we use this same exact method for the uppercase letters. Okay, wow. So we finished the encrypt function, and now we return to the main function. Next, we call the show encryption function to display the original and the encrypted words in 2 columns aligned to the right. This function receives the two vectors of strings, one for the vector with the original words and the other for the encrypted words. We first start with a variable called max word length, initialized to 0. What the heck is that size underscore t? It is of type int, but for syntax purposes, I am using that size underscore t. We have a for loop that iterates through all the words of the vector, words v, and finds the word with the largest length. If you recall, while entering our encrypted message, we saw two columns that were aligned to the right. But how far away? The length of the max word length, far away. We do this by assigning the max word length to the size of the largest word. If the size of the current word is larger than the max word length, that current word size is the new max word length. We use this variable inside of the for loop where the actual displaying is done. Again, it iterates through the entire size of words v. These two lines is the code that displays each letter in lowercase. It works by iterating through the entire word, character by character, transforming it into lowercase until the end. It is worth noting that this transformation is done in the same memory location, indicating that the word is modified rather than copied in another location, and it does this for both the words in the vector of the original and the encrypted words. We next have a caption that prints the words from both vectors and aligns the words to the right using this set width. This set width indicates the length of the space where the string is going to be printed, and because we have set to max word length, the length from here to here is going to equal the length of the max word length. Finally, we come back to the main, where we prompt the user if he would like to encrypt another message. The program reads his answer. Here we clear the words of the previous loop so it is empty for the next displaying of the words. While the user enter is yes for his answer, the loop continues, and if not, the loop breaks. Finally, the program returns 0. Thank you for watching.